IPv6 here, but it's all right. It's fun doing it from home. Actually, I enjoy doing it from home because um, it's a non-Cisco router, and it's probably more. It's interesting. Um, yeah, we'll talk a little bit about it today. The defaults that Cisco uses different than other vendors, and why don't they change their defaults? We'll talk about it. See what I'm talking about here with some of these lifetimes and timers here in a moment. But the thing is, once you set a default as a vendor in your operating system, changing it is a kind of a big deal. Yes, Pamela.
Sorry, Rick, my puppy stepped on the keyboard. I'm sorry.
Well, does your puppy have a question?
Yeah, he probably does, but.
Oh, okay.
Okay, sorry about that.
That's pretty funny. Oh, I see the paw instead of the hand. Sorry, I should have noticed that. John shared with us, or shared with me, this is, so there was a couple of mistakes in my router advertisement presentation. I copy and paste, you're getting most of these are all new slides that you're getting. So, which is, it's a lot of fun for me. It's, I enjoy doing it. A lot of work, but it's a lot of fun. I enjoy doing it. So I had pulled, let me see if I can find that slide here. This one here, I had 1, 2, 3, 4, 5, 6, 7. I have 8 now. I had 9. I had an extra octet in there. So so what would that make it? 140-bit address, 142-bit address. That wouldn't have been good. And I was using FF01 here instead of FF02. It really doesn't matter. It does matter. They are your computer NIC card accepts all IPv6. Anything to FF01 :1 FF02 :1. That means all IPv6 devices. This is what you're going to see because this is what's coming into the NIC card from the outside world. This is link local. This one here is interface local. This would only be what you're sending to yourself, usually for testing purposes. All right, let me get that out of the way. And John, just to make sure that Rick has his stuff together, which is always good to check on Rick. IANA. So IANA, the folks that they are kind of the Internet Assigned Numbers Authority. They're the ones that are the primary holders and allocators of IPv4 addresses and IPv6 addresses to the regional internet registries. At one time, we saw that they actually handed them out right to organizations. So that was really nice, like UCSC. There's all kinds of addresses. But they also are the ones that handle assignments. They don't actually do the operations side of this stuff. They usually give this off to other groups like ICANN for IP addressing. But you'll find that they also on their website has things for port numbers, UDP, TCP port numbers, and also multicast, IPv4 and IPv6. So here's the IPv6 stuff so you can see everything here. See, here's all that scope. Interface local, link local. So this is usually what we're going to see, but here's all the different multicast, link local. So a lot of router stuff. So also like OSPF. This is, if a router, just a little side note here. If you and I are routers, we are sharing a link with each other. Okay, we have a network, a link between us. We both have IPv6 addresses on that link. Typically, we'll have link local, probably have global unicast addresses too. When we are sharing, when I'm sending you an OSPF update message, I would send it to this multicast address. This is I'd send it out my interface and I'd say, hey, this is for anybody out there that is an OSPF router. Um, if you are an OSPF router, you'll accept this. This is an OSPF update. And if you're enabled for OSPF, then you'll accept packets to this destination IP address. Now, what's interesting is the IPv4 equivalent is, so the IPv4 address for multicast is 224. So in IPv4, I would send it, it would be sent to 224.0.0.5. In IPv6, it just uses this multicast link local, all zeros and a 5. So they try to keep these numbers somewhat consistent here. Even with EIGRP, it's A here, it's 10 in decimal for IPv4. So, John Moy, John Postel. So we heard about John Postel. John Moy, by the way, is the one that wrote the RFC and did a lot of the initial work on OSPF routing protocol. I always like to mention the names because people that did this stuff, this isn't like, just some, it's not like, some anonymous corporation or some big corporation, just hundreds of people all develop something. These are a lot of times are individuals that create these standards. All right, so today we're going to start talking about Slack. And we're going to continue this conversation on, this is Thursday, right? On Tuesday. You get a holiday and it completely throws me off. So today we're going to talk about Slack. My allergies. Excuse me. Stateless address auto configuration. We're going to begin with reviewing the router advertisement and then ease our way into Slack. So let's get started here. So we saw that with IPv6, how a device gets its own IPv6 addressing information dynamically. It's all up to the router advertisement. Okay, we saw that devices create their own link local address. Okay, typically what they do is just, use FE80 and then the last 64 bits is random. So they create this and then they get the rest of the information from the router advertisement message. Okay, what we're going to look at today and this week is we're going to focus on Slack. And we began that last week with looking at the router advertisement message, or on Tuesday, looking at this. So we'll look at some of this again here in a moment. But so the router sends out a router advertisement message. And again, once again, it's a router advertisement message is an ICMP v6 message, similar to what we use ICMP for things like echo request, echo replies, pings, that sort of thing. But in this case, it's a router advertisement. And it includes things like the prefix length, the prefix and the prefix length, and any flags like the A flag, which is used for Slack, the address auto configuration flag. Now, this is encapsulated in an IPv6 header. The destination IPv6 is the multicast address that I just mentioned. It's the all IPv6 devices or all IPv6 nodes. If we look at the IANA, what they have, again, right here, IANA. Okay, they say call it nodes, all IPv6 nodes. Let's go here, link local scope. Okay, so we can see right here all nodes address. Okay, so that means any device enabled for IPv6, this is for you. The source IPv6 address is going to be the link local address of this device. We're going to see how that's used here in a moment. Okay, so we're going to see that, well, devices are going to use this address as their default gateway. And it's guaranteed to be something they can reach because this is first of all, it's a source IPv6 address of this interface that's sending the message. But more than that, because, it could be a source IPv6 address from a router or device on another network. But more than that, because it's a link local address, it's guaranteed to be on this link. Meaning it's a device that, it's a address that these devices are guaranteed to be able to reach. So that puts an extra guarantee, yes, I can get to my local post office. Okay, so this is the data. IPv6 header, ICMPv6 header. Okay, now let's build the Ethernet frame. The source MAC address is the MAC address of this Ethernet NIC that's sending it out. The destination MAC address, and we took a look at this last week. 3333 means that this is a multicast address that is for an Ethernet frame that is containing, meaning this is for a container, has, for IPv6. So this all zeros and a one corresponds to the all zeros and a one here in this address here. So NIC cards, these network interface cards here, will accept it if their operating systems enabled for IPv6, which it is by default, which means their NIC card has been told, hey, accept any Ethernet frames for this multicast group. You now belong to this multicast group. Okay. Matter of fact, I like that. So I like what I just said so much. I'm going to put that right here. That these devices, excuse me 1 second. I don't want to forget that. I like what I just said there. These devices here, we belong to this multicast group. I'll just kind of put this here for now. Okay. Kind of see that. All right. Do that. All right. And then it adds the type, which says, the type field just says, hey, I'm carrying the data that I'm carrying is IPv6. And it sends it on its way. All right, so let's again take a quick look at this router advertisement, because we're going to take a look at it in more detail in a moment. We're going to look at two versions. This is the one from my house. We're going to take a closer look at this in a moment. But we're also going to take a look at one from a Cisco iOS router. So we're going to look at two different routers sending out a router advertisement, because it matters what's in that router advertisement, what they want to put in it. It kind of gives us an idea. We're going to see, and then this is why I like talking about this. I'm going to take it slow. This is what the end user, this is what's going to affect the end user and all of our client devices. Okay, so here's the Ethernet frame, just saying it once again, it's from this going to this destination MAC address, and this is the source MAC address. So we really get to see all this. We're carrying an IPv6 packet. There's the source IPv6 address. Again, this tells all of the devices, this is your default gateway. Okay, now that's not just because this is an IPv6 header, but because the router, it's carrying a router advertisement message. Okay, there's the destination IPv6 address, which is the all IPv6 devices multicast. Again, the all zeros and a one here corresponds to the all zeros and a one here. Okay, and it says, what am I carrying inside? I'm carrying, encapsulated. I'm carrying an ICMP v6 message. Okay, right there. So let's go there. Here's the ICMP v6 message. Type code fields. We saw this in CIS 81 this week. This means that this is for type 134, code 0, means this is a router advertisement message. Okay, on my Comcast router at home, flags are set for managed and other configuration flag. We'll address that later. it says this is your prefix. Okay. I'm going to talk more about this in more detail here in a moment, but says this is announcing, hey, telling Rick's computer, this is the network you belong to, and this is the prefix length. And I'm setting the A flag to 1, or have set it to 1. That means, hey, create your own address. Okay. I'm giving you what you need for the network portion, the prefix and prefix length. You create your own interface ID, however you want to do that, using those values. Okay. We're going to talk about these valid and preferred lifetimes. 300 seconds, 300 seconds, 5 minutes. Going to talk about those. And we're going to take it slow as we're going to revisit it, same topic on Tuesday. Okay. This is kind of the strange thing here. Not strange, it's just, people look at this and their eyes gloss over because they don't understand it. We're going to understand it, but we'll take it slow. All right, what else we got here? Oh, there we go. There's our DNS server. So it says, hey, you use this to, if you have, the domain, somebody typed in a domain name, need the IPv6 address, here's the servers you can ask. Give you the IPv6 address. All right, so we saw that IPv6, we've talked about this in the past, I've got to sneeze here, gives you both a permanent or a public address and also a temporary address, okay? Excuse me, 1 second. You knew what happened, right? As soon as you walk away, you can't sneeze. All right. So I'll just sneeze in front of all of you here in a second. All right. So we have this permanent or public address and a temporary address. We're going to talk a lot about this today and on Tuesday. How do I know this is the permanent? It says secured. How do I know this is the temporary? Well, it's a little temporary. They're both automatically configured. Okay, so basically I used the prefix length, the prefix length that was in the router advertisement. And that's my first 1, 2, 3, 4 hextets, the network, 1, 2, 3, 4, the network, and created my own interface ID, 1, 2, 3, 4. There's the interface ID, 1, 2, 3, 4. Okay, so we talked about this a little bit, introduced it on Tuesday. But these are randomized interface IDs, the last 64 bits, meaning they're not using the MAC address. And hopefully, they shouldn't be traceable. So, so we're going to see that it creates relatively short lifetimes, relatively, meaning the lifetime of a temporary address should be shorter relatively to the permanent address. And we're going to talk about that, going to introduce that today. So we're going to see that the temporary address is used anytime my device is making a connection to a server, which is 99.9999% of the time as for a client, or really closer to 100% for most of us. So this is anytime you're doing anything. Okay, it's going to use your temporary address to make the connection, and your server will use your temporary address use that address. It doesn't care if it's temporary or not, just sees it as an IPv6 address and sends it directly to you. Again, no network address translation. Now, the permanent address is used if you want a device from outside your network to connect to your computer. Just need to make sure you open that up in your firewall. Most home routers, most enterprise routers too, don't allow that by default. Okay, so you actually have to set that up. So this doesn't make you inherently, IPv6 doesn't all of a sudden make your devices less secure. Now, you know, it's not going to happen anyway unless you open up that address and port to allow these devices to come in, and then you can connect to those. By the way, that's the same with IPv4, and you know what? It's the same even if you use NAT. I won't get into that, but you know, it's you know, NAT. Yeah, I won't get into it. But NAT isn't any. You know, NAT. If you're using NAT, and you think, oh, I've got a private address inside and I'm connected to the outside world, although it's very difficult for somebody to do this, if they know the port number you're using and your public IP address, they could try to connect to you. All right, I'll leave that aside. Sorry to go off on that tangent. So let's look at Cisco IOS router advertisement. Okay, so the Cisco router advertisement, okay, so we're going to send it out here. So we're going to, you know, I don't think I need to go through any of this here. Let's just look at the router advertisement message here. Okay, for Cisco routers to send out a router advertisement message to route for IPv6, we have to do IPv6 unicast routing. Okay, if I do show IPv6 interface in one of my interfaces, I will now see this down here. Well, first of all, let's start right here. Joined group addresses. This says I am now an IPv6 router, which means I have joined this multicast group. Yeah, let's bring this across here. I've joined this group here. I'm the all IPv6 routers multicast group now. I've joined that group. I was already a member of FF02:1, the all IPv6 devices multicast group, FF02:1, just by, once I have a linked local address on that interface, hey, I'm a member of that group. I'm an IPv6 device. Your client operating system on your phone and your computers or whatever are automatically a member of this group. Okay, you have a linked local address, even if you're not on an IPv6 network, doesn't matter. This, you're not a member of. Our computers are not a member of this group. Could we be? Sure. But by default, we are not. Cisco routers, by default, are not a member of this group. Even if we put an IPv6 address on the interface, it's not a member of that group. Not until we say IPv6 unicast routing. Now it's a member of that group. And when we did IPv6 unicast routing, reason why it requires this is because now the router is going to send out router advertisement messages. Okay. Now, Cisco IOS, let's go through this. Let me do it like this. Right? So we're a member of the all IPv6 routers multicast group. The MTU is 1500 bytes. This is going to be in the router advertisement message. But this is going to inform hosts, as we're going to see here in a moment, that, hey, the size of your IPv6 packet, along with any transport layer headers, TCP, UDP, data, and everything else, should be all together 1500 bytes, because it's going to go inside an Ethernet frame. See that in a moment. Okay. All right. So this here says send out the router advertisement message every 200 seconds. That's Cisco default. Router advertisement messages live for 1800 seconds. Okay, what this means is this tells the host that this is how long this information is good for. Okay, so some of the information that you're going to be getting in this router advertisement is telling you that I'm your default gateway. Okay, so 1800 seconds. Okay, that is, we're going to take a look at the router advertisement more in a moment here. Don't worry about this 0 here. But it says this is how long this run, but you're going to hear from me every 200 seconds. Okay, so you're going to get several attempts here before this expires. So every time you get a router advertisement from me every 200 seconds, refresh this 1800 seconds. This router advertisement and the information I'm giving you is still good. Okay. So the default is 30 minutes. Okay. But every 200 seconds, what is that? 3 minutes and 20 seconds? Do I have my math right? 3 times 60 is 180 plus 20. Just over every 3 minutes, you're going to be hearing a router advertisement from me, and this will get refreshed. We'll look at this more in a moment here. We're going to look at the router advertisement. I'm letting you know that I can be used as your default router, your default gateway. Preference is medium. What does that mean? That means there's 3 preferences. There's high, medium, or low. And yes, it's possible that you have multiple routers on your network. Think about this. We don't think about this with IPv4 by default. You have one default gateway. With IPv6, I can have multiple routers. And I could be getting router advertisements from let's say all 3 routers. Which one am I going to use as my default gateway by default? Now, if they're all set to medium, I'll typically use the first one I receive, the first router advertisement I receive. But as a network administrator, if I want to make one of them the preferred way out for my clients, I can set it at high and make the other ones medium or low. So I can have an order of magnitude of, well, not magnitude, but a priority of high, medium, or low. Now, is this the best? Yeah. So anyway, kind of cool. Inherent in IPv6. Now, in CIS-82, we're going to talk about how to have multiple default gateways, multiple routers in IPv4 using something called first hop redundancy protocol. Works for both IPv4 and IPv6. You have to use that if you have multiple default gateways in IPv4. IPv6, you can actually do it this way. Does that make sense? Do I need to explain that a little bit more?
If we have time, it wouldn't hurt.
Okay, we have time.
Thank you.
Yeah, so let me bring this up here. I need to go. So we have a computer here. Okay, connected to, let's just make it an Ethernet switch here. Okay, we have 3 routers. Router 1, router 2. So I like teaching this class because this wasn't something I was going to talk about, but this is great. I do want to talk about this. Router 3. Okay, so let's say they all have FE80. This is their link local addresses. 1. So this is 1. This is double colon. I'll just put double colon here. This is double colon 2 as its link local address. And this is double colon 3 as its link local address. Okay. So all 3 of these routers are sending router advertisement messages. Okay. Now, the host is going to get the same prefix from all of them. They're all on the same network. So this host is going to get the same prefix length. So it's going to use, say our network is 2001 DB8 cafe 1 64. They all have global unicast addresses on this network. So they're all going to send a router advertisement saying this is your prefix and prefix line. So this device will just create using this information and its own interface ID, 64-bit interface ID using this prefix. Okay. Now, what is it going to use for its default gateway? Okay, so it says, what's my default gateway? Okay, remember, it's going to use the source IPv6 address of the router advertisement, which is coming from these link local addresses. Okay, if the default the router preference okay is it's high, medium, or low. The default is medium. The default is medium. So this device here we use for its default gateway, whichever one it received first. Let's say it got the double colon 2 first, okay? You're my way out of here. So that's what it's going to use. That will keep the other ones that it got. Say it got 1 next and 3 next. So it has a list. It actually has a list of default gateways. If this one here is no longer valid, then it can use this way out. Kind of cool, right? But what if we want to tell our users, no, we want this one here to be the preferred way out? We can set it to high, the default router preference. So that will say, oh, okay, you're not the preferred way out. Okay, you're the preferred way out. Okay, and this will be the default gateway. Does that make sense? Okay. Good question. Maybe if we have time, I'll talk more about this later. Very cool stuff. Okay, so that's the default router preference. And we're going to see this in the actual advertisement. Okay. And this is just saying host use stateless auto config for addresses. So this is just saying on this interface, I'm sending it out router advertisement messages with this information here. And this is saying, by the way, my A flag is set to 1. That's what I'm telling them to use. Okay, so it just kind of gives you a summary of the router advertisement message that is being sent on this interface. This is a summary of the RA, the router advertisement message. Okay. All right. This is what it would look like if I did debug IPv6 ND. Okay. This is showing that router advertisement message is good for 1800 seconds. There's the MTU. There's the prefix length, LA. It's a the router's in Los Angeles. No, I'm just kidding. These are 2 flags. We'll talk about both of these. What link you're on, and there's the A flag. So yeah, so this is saying I'm sending this is, so let me explain this once again. IPv6 unicast routing. The router will now start sending router advertisements out, all Ethernet interfaces. Debug IPv6 ND. ND stands for neighbor discovery. This will start showing me any messages on my console that are part of ICMP v6 neighbor discovery events. Okay, this includes router advertisements, router solicitations, neighbor advertisements, neighbor solicitations, ND. So that's the neighbor discovery. So this here is actually showing me router advertisements, the RA. By the way, you want to be, if I didn't mention this before, let me mention it again. Debug is a wonderful tool that lets you see what the router is doing, what it is processing, what it is sending out, what it is receiving. On Tuesday, I'll log into one of our data center routers, and I'll show you the list of things you can do. You do want to be careful with debug on a production network. If you are debugging too much or choose something like debug IP packet, which is showing everything to do with IP packets, that's not going to be good. Probably overwhelm your CPU and probably bring down the router. So So you only want to do it for a short amount, when you need it, and you want to do undebug all when you're done. All right. So this here is saying I'm sending out a router advertisement message. This is the destination IPv6 address. It's going out to all IPv6 devices on that link local. Okay, sending it out of this interface, gigabit 00. Here's the source IPv6 address. Okay, FE80:1. This is the address devices will use as their default gateway. They'll add it to what's called their default router list. Typically, it has one router in it. This says I'm sending the router advertisement message. The 1800 is the duration in seconds. How long the clients who receive this router advertisement should consider this router advertisement good for, the information in it, including me as your default gateway. I'm sending it from FE80:1. I'm good for 1800 seconds, 30 minutes, but this gets refreshed every time you get an router advertisement from me, letting you know, hey, I'm still here. I'm still here. I'm still here. Oh, okay, good. You're my router, right? Yeah, you're my default gateway. I'll keep on refreshing that. Okay, all we know about that, the MTU. This is the size that devices should use to create their IPv6 packets. This is the prefix and prefix length. Talk more about that. The LA, so the L flag, very interesting. So here's a little bit of that people don't realize. Remember in IPv4? Oh, how can we not remember IPv4? So in IPv4, I'm bringing up something here. I'm bringing up my system settings. Okay, I go here to network. Okay, I go here to my computer. Okay, so there's my, hopefully you can see that okay. Here's my IP address. Okay, but remember the IP address by itself doesn't tell you what network you belong to. What my device has to do is it gets this subnet mask. Okay, also from DHCP, or if I type this in statically. So this is going to tell me what network I belong to. So using my subnet mask here, I know that those 3255s, that this is the network portion of my address, which means I can reach any device without going to a router. I can send any message, any IP packet directly to another device without sending it to the router. I can encapsulate an Ethernet frame from me to that device, as long as from my NIC card, my MAC address to that device's MAC address, as long as the destination IP address starts with this. Okay. But the subnet mask is what's used to determine what network I belong to. In IPv6, no. See this L? That's known as the on-link flag. What that's telling the device is this is the network you belong to. You don't have to figure it out, okay? You don't have to worry, I'm letting you, this is the network you belong to. Okay, so you can reach any device locally. And why do they do that? It's just perhaps future options that devices, so I won't, it just gives you more flexibility, more of those knobs that you shouldn't touch unless you need it. Okay, the A flag here says, by the way, my A flag is set. So what I'm suggesting to you, and the router advertisement is always a suggestion to the client. It's not like, no, you must do this. I'm suggesting. The operating system can always do whatever it wants. But I'm suggesting that you create your own address using this prefix line, just create your own interface ID. Okay, we're going to talk about these valid and preferred lifetimes. We should be able to get to that today. If we're not, I'm not worried about it. We'll get to it on Tuesday. I'm kind of halfway thinking Tuesday is better, so we can jump right into there. All right, here's the end result in this case here. Okay, all of this I'm going to talk more about here, but there's the prefix. Okay, I created my own permanent address, public address, and a temporary address. And I use the link local address, the source IPv6 address of the router advertisement, which is a link local address, as my default gateway. Okay. We'll talk about these here in a moment. Yeah, I got a lot coming up about these. We're going to talk about public temporary addresses more. One other thing with Cisco IOS that you have to do is you have to also include, if you want to include the DNS server address in the router advertisement. That's a separate command. And this goes back to when the history of this is not all devices would supported sending out a DNS address in the router advertisement. So this just telling the devices, I'm going to include this in the router advertisement now. This is in the router advertisement I'm going to send you. This is the address of our DNS server that you should use. That's IPv6, neighbor discovery, router advertisement, DNS server, and I think you can have up to 9 of these addresses. Okay. And we can actually see that it's actually being included now in the router advertisement message. All right, how are we doing? Boy, I've been talking for a long time.
Rick, it's still a lot, but you said that's okay, so.
Yes, definitely okay.
Okay.
Definitely okay. Yeah. And you got to remember, you're getting exposed and familiar to, at least at a certain level, this is new stuff, although it's been around for going on 30 years. For most people in IT, this is brand new. Yeah. So again, if you watch like that, those Nanog videos, you'll see that, there are people working in ISPs, senior network engineers that are just getting familiar with this stuff. Yeah. Let's do this. Let's take a 5-minute break. Okay. So I don't and then I'm gonna show you the router advertisement messages. I'm gonna show you, first of all, what it looks from a Cisco router, and then my Comcast router. I'm gonna show you 2 different approaches that they use. And I think the Comcast one is a little bit more, I like it better, but you can always change these values. What is Rick talking about? We'll get there after the break. So let's go ahead and do 8 minutes. And who's going to be in charge of telling Rick to restart the recording?
Do you want me to send a chat message? Would that help?
No, as soon as I begin, just go, are you recording? Or a chat message.
Okay.
Whatever, anything. Or come over here and just hit me on the side of the head.
Okay, I can do it.
All right.
Recording stopped.
I'm back. All right, I'm gonna start the recording.
Okay, perfect.
Thank you.
Thanks.
Recording in progress.
There we go. This is a photo. Pretty much. So this is from a RIPE and NCC meeting. RIPE NCC is one of the 5 regional internet registries. And so they all do different conferences and things. It's similar to like what NANOG does and all these conferences. A lot centered around large companies, enterprises, ISPs, but even anybody, So this is from their conference that they showed this. So IPv4, enter the past, the elevators, IPv6, enter the future. Thought that was interesting. And then, of course, we get these kinds of things all the time. At least I do. Let's see, make sure I bring up the right one here. So, yes, you can get Legos now supports IPv6. Actually, that's, of course, not real. There's a AI program site that creates these Lego things. Now, what I'm impressed by this one is a lot of times they don't always get the, whatever you put in there. Yeah, see, they're missing right there a little bit. Don't get it correct, but they've got all kinds of different ones out there that people post. Okay. All right. I sneezed, so that helped. You probably heard me because I didn't mute myself. Okay, let's look at a router advertisement coming from a Cisco iOS router. And most of the stuff, not a big, it's kind of generic, but there'll be a couple of differences when we look at Comcast. All right, so the type indicates a router advertisement message, that current hop limit. This recommends to devices, this is what you should use as your hop limit field, similar to time to live field in for IPv6. Okay, again, suggestion, recommendation. Okay. If this value is 0, doesn't mean to use a 0, it just means I'm not recommending it. But your operating system is going to do what your operating system wants to do. It can either use this recommendation or it can just say, I'm going to do my own thing. And by the way, a lot of especially with Linux and Mac OS, you have a little bit more control. And I'm sure Windows do too. I'm a little less familiar with Windows, but to actually set things. But always, hey, best to use the defaults. So this here is our flags. Now this isn't all the flags. This is the managed address flag, which is not set, it's 0, and other configuration flag, which is 0. This is used, so if this managed flag was set to 1, this would mean use stateful DHCP v6 server to get your your global unicast address. Okay, but it's set to 0, so we'll talk about stateful DHCP v6 later. 0 of the other configuration flag, that's also set to 0. If that was a 1, that would say, this is typically used with Slack, the A flag. This means, hey, after you create your own address, talk to a stateless server, not for a global unicast address, but generic information that's given to everybody, like maybe the address of a DNS server. We'll talk more about DHCP v6, stateful and stateless, a little later. This is the router preference. Okay, so this is where we can actually change that. So 0, so it's known as 0, 0, which is medium. 0, 1 is high, 1, 1 is low. Okay, default is medium. Router lifetime. So this is the duration in seconds, which says this is how long you should, consider my router advertisement as being valid. I want to use valid because we use that term later. Maybe active. And that mostly refers to me being your default gateway. Remember, I'm sending you this router advertisement from my source IPv6 address, which is a link local address, which you're going to use as your default gateway. So that address you're using as your default gateway, It's good for 30 minutes, okay, 1800 seconds. But every time I send you a router advertisement message, which Cisco is defaults to 200 seconds, about 3.5 minutes, refresh it and let you know I'm still out here. Still your default gateway. Yeah, default is 1800 seconds or about 30 minutes. Okay. All right, I'm letting you know this is my layer 2 address. Now, you know my link local address, FE80:1. That's what I sent the source IPv6 address of the packet. So you don't have to send me a equivalent to an ARP request in IPv6 to get my MAC address. Here's my MAC address. My MAC address associated with my link local address, put that in what's equivalent to an ARP table in IPv6. So anytime you need to send packets outside the network, encapsulate them in this encapsulated in a Ethernet frame with this as your destination MAC address. This is my MAC address. You can send those packets in a frame with this destination MAC address. Okay. By the way, I will talk about it in IPv6. It's similar to ARP. It's called Neighbor Discovery. It actually uses ICMP v6, neighbor discovery, neighbor advertisement, neighbor solicitation messages. There's something similar to an ARP table known as just called a neighbor discovery table. So we'll talk about that later. There's that MTU again. This is what you should use for as far as the size of your IPv6 packets. Okay. Any questions on that so far? All right.
Oh,
Pretty big slide.
What does it mean by? Oh.
Question? Oh, no.
Oh, yeah. I'm sorry. What does it mean by size of the packet?
That's okay. So that's just, yeah. So let me make sure what that is.
Sorry.
No, that's fine. Why we're here. Okay. So what we mean by that, let me back up. Okay. What this here means is the data. So this is, so remember Ethernet, we have the Ethernet header, okay, which is the destination MAC address, source MAC address, and the type field, which says this is IPv6. We have a frame check sequence for error detection. Okay. This along with this whole thing here, let me kind of, the whole size of this Ethernet frame from here to here is 1,518 bytes. The header and the trailer take up 18 bytes. So what that's saying is the MTU is saying for the data, which is your IPv6, could be your IPv6 packet, is 1,500 bytes.
Oh, okay. I remember. Okay,
Yep.
I remember that. Okay, thank you.
No, good question. Yeah, so that's what they mean by the MTU. Yeah. Yeah, Pamela.
Rick, to follow up on that, and I apologize if you've already explained this, but if it's more than 1,500 in terms of all the data that you're sending, then it will just be multiple packets.
Oh, yeah. Yeah, so usually when you're downloading data from a site, a web page or something, images, whatever, yeah, it's going to be could be many huge files, right? So what it does is it segments this data up. Okay, so it's going to take the data, all that data. This is all data here. And it's going to break it up. Now, for IPv6, okay, we've got 1,500 bytes here. So what do we have? We have 40 bytes for the IPv6 header. That's the IPv6 header is 40 bytes. If we're using TCP, which we're going to be talking about next week, that's 20 bytes. So that's 60 bytes right there. So what do we have for the actual data left over of these here? Okay, well, that would mean we have 1,440 bytes. Did I do that right? Yeah. So each one of the data itself that's being sent would be broken up into 1,440 bytes, 1,440 bytes. So each one of these would be encapsulated in a separate IP packet. There's the data, the 1,440 bytes, separate TCP header. I'll just put a T there, separate IPv6 header, and a separate Ethernet header and Ethernet frame as it goes out your NIC card. This would be the packet that's sent. The IP header, TCP header, and the data itself. Each one of these is going to get its own little unit of encapsulation and be sent separately. Okay. Does that make sense?
Yeah, thanks.
Great question. Great question. I mean, we go, so all of this stuff is, just, these are both really good questions because in our classes, yes, we talk about this. I think I mentioned like day 2 of CIS 81. Well, where were we day 2? This is where things begin to make sense. I said, where this stuff makes more sense is when you cover this again in other classes. It'll all start coming together more and more and more. Okay. All right. So that's, and by the way, this would be the MTU for IPv4 as well. The only difference is the header is 20 bytes less. So you'd have 20 bytes more of data. Okay, so so we were clear on that with IPv4, if we'll be talking about this next week with TCP, you have a 20 byte header, you have 20 bytes for TCP, so the data would be 1,460 bytes. So that means that tells the end unit, the client or the server, when I send data, now I can send it as 1,460 bytes if it's IPv4. I can throw in an extra 20 bytes. Yeah. Does that make sense?
Yes, it does. Thank you.
Yes, thank you.
Yeah, good questions. Oops, I almost hit the line. There we go. There we go. Okay. I closed something here like my ink to go, and somewhere behind some other screen on some other screen behind some other window is where I got to click OK, and I got to find it. All right. This is the prefix length. Okay. Boy, why aren't I showing you the prefix to it? I'm gonna put those together here. I think I'll probably do them here, right here. Let me put that right there. Okay, the prefix and prefix length. So this is letting the device know this is what network you're on. Okay, now we're gonna see the A flag is gonna be set here in a moment. But this is also telling you what, and the on link flag. Okay, so the prefix and prefix length tells you what network you're on. Okay, here's the on link flag. So that says, remember I told you what prefix you belong to, what network? Prefix length? That's what network you belong to. Okay. The A flag is, in this case, set to 1. That's default on Cisco routers. So when it says default here, this is Cisco iOS defaults. Okay. So when this default, so this is default of 1. So this tells devices, create your own IPv6 address automatically. Do it yourself. However you want to do it, EUI64, use random bits, whatever you want to do, you do it. Okay. Now we're going to come back to this valid and preferred lifetimes. We're not going to do this today. We're going to cover this on Tuesday, which I think is better. Okay. But this is going to say how long your public address, your permanent address is good for. Now, for Cisco iOS, it says it's suggesting to the end device that your IPv6 address that you can use as your permanent one. We'll talk about temporary also, but for your permanent one, good for 30 days. And will get refreshed every time you get a router advertisement message. It's preferred for, we'll talk more about this, 7 days. Meaning, so we'll talk more about this later. But basically this means people can reach you on that public address, the permanent IPv6 address for 7 days. You can, that's how good it's for. Now we continue to be good for another 30 days. I'll talk more about this later. As long as it's still in use. If somebody still needs to use it, they can. We'll talk more about that later. So let's not worry about that right now. There's the prefix, once again. All right. And there's our DNS server address. Okay, so this is telling devices use this as your DNS server. Ignore what I said for right now on valid and preferred lifetimes. We're going to get there Tuesday. Okay, let's look at Comcast. Okay. Because this isn't all about Cisco, right? It's whatever, home routers are going to be playing a major part of this. Cisco, sure, enterprises. But most people are not going to put a Cisco router at home. Not that, your vendor might use a router made by Cisco or just using Cisco iOS or Meraki or something. I don't know. Okay, but you're going to see it's very much the same thing. So here's my home router. Notice the same ICMP v6 message. 1/3 type, 134 code 0. Okay? Okay, it's router advertisement message. Same thing, it's suggesting same hop limit, 64. Okay, all right. Now, this was set to 0 for Cisco iOS. Managed address configuration and the other configuration flag. This is telling my device to get an address. So it's giving me every option possible. There's 3 flags that are set in Cisco for the router advertisement. 3 flags that say how to get your address. There's the A flag, which means use Slack, create it yourself. We have the O flag, that it means, that's going to be with the A flag. So that's the A flag is used. If you're going to use the O flag, you're using it with the A flag. And that means get other information like, generic information like a DNS server address. And then there's another flag called the M flag. That means get your address from a DHCP v6 server. This is coming from a state list. This is coming from DHCP. But this is coming from a server that's only giving you something like a DNS server address. Something that it's going to give you and everybody else the same information. It's not giving you your global unicast address. You created your global unicast address. The address doesn't matter whether it's temporary or permanent. You created this. The address you're going to use to connect to everybody and the internet. You created this, Slack. or you can get your global unicast address assigned to you from a DHCP v6 server. What Comcast does is says, do this, create your own address, and it says, just in case, we have a DHCP v6 server. We'd like you to see if there's any other information you need. You know what? Also contact us. We'll give you another global unicast address that we'll assign to you. We're using all options. Why is it doing that? Not sure, except maybe it says, in case, it does, doesn't hurt for you to have all this extra stuff. We'll talk about which one. This is what your computer's going to use by default. Okay? This is kind of a oddball, extra. So it's kind of weird. It's, not, you usually don't use all three. Comcast does by default. It's not a big deal. But we'll see all three, we'll see all these addresses and where they came from in a moment. So just bear with me. It's kind of weird, but hey, that's why you're taking this class, is so you understand that, hey, these are all the possibilities. It's just not one or the other. It's turning on all these knobs, and it's okay. All right. Okay, I talked about those. Here's the default router preference. Okay, it just says, hey, I'm your default gateway, medium, by default. Okay. Lifetime. Oops, I got the wrong, I did the copy. 180 seconds. Okay, there we go. Thought I changed that. 180 seconds. So this says, use me, I'm good for 3 minutes. Now we're gonna see, what? Yeah, use this router advertisement. It's only good for 3 minutes. Remember what Cisco was? 30 minutes. You know how often a Cisco iOS sends out the router advertisement message? Every 3.5 minutes. Okay. I'm probably confusing you here a little bit. We'll come back to that. Okay. It's saying here are your DNS server addresses. Giving those to you. Again, here's the prefix and prefix length. The A flag is set. Oh, here's the on-link flag. And the A flag is set. This is the network you belong to. And here's the A flag. Create your own address using this. It will come back to these 5-minute addresses here in a minute, not on Tuesday, how the valid preferred lifetime. What I want to do is mention this. This is Wireshark showing the router advertisements at home. Here's how often I'm receiving them. In seconds. Every 3 seconds. So let's talk about this for a moment. So here's my Comcast router. And it's sending router advertisement messages out to my devices. And it's sending them every 3 seconds. Okay. Yeah, let me actually. Okay, let's do Cisco first, and then we'll do Comcast. Cisco, Comcast. Different approach, and I'll talk a little bit maybe about why. Here's the router, Cisco router. Okay. We have our network here. All right, put a little switch here. Okay, computer, it's computer, other computers, sending out a router advertisement message. Okay. This router advertisement message is being sent every 3 seconds. Oh, no. sorry, Cisco. Every 200 seconds. Okay, every 3+ minutes. Okay, and by the way, it said I'm good for 1800 seconds, meaning me as your default gateway is good for 30 minutes. We can get rid of the plus there so we don't get confused. We'll just make it 3 minutes. So every 3 minutes, I'm going to send you a router advertisement. Coming from my link local address, that will be your default gateway. Whatever the link local address is that sent the router advertisement. Are we good with that? Does that make sense?
Yeah.
Okay. Now, if this router goes down, okay, and you know, it could be up close to 30 minutes before this device here says, oh, you're not my default gateway anymore. Because that default gateway is good for 30 minutes. That's what this here is. How long this router, how valid, you know, this router advertisement is valid for 30 minutes. Which means you as my default gateway is good for 30 minutes. So even if I had another router, I might still prefer you. That's okay. So now let's take a look at Comcast. Switch here. And a computer. Okay. Setting the router advertisement from its link local address. This router advertisement is sent every 3 seconds. Okay. And it says it's good for 180 seconds. Good for. This is sent. So this is sent every 3 seconds. And it's good for 180 seconds. 3 minutes. Good for. Okay. Now Comcast has I'll get to this in a moment. Why the difference here? So, in this case here, the default gateway address, my link local address is good for 3 minutes. If I don't get a router advertisement from, let's go up here. If I don't get a router advertisement from you, something happens. The router goes down, the link goes down, this router goes down. As far as this device here says, you're still my default gateway for the next 30 minutes. That's not really great failover redundancy. There's other things we can do, but this isn't, one thing we can do in Cisco IOS is actually we can change this, by the way. Okay, it's sent every 200 seconds. We can change how long it's good for, but this is the default. You can change it, but the default is you're good for 30 minutes. Here, every 3 seconds, I'm letting you know I'm here. You're good for 3 minutes. So if something happens with this router and we have another router, it will say, oh, after no longer than 3 minutes, I'll say, hey, you're no longer my default gateway. So why does Cisco have such high numbers? Well, this was their default early on. Gosh, since iOS 12, you know, I would easily going on 15 years, 20 years, something. You don't want to just changing a default means that if somebody is assuming this is their default and they've architect their network around these defaults. If you change it, meaning we upgrade the iOS to a new version, and these defaults change 200 seconds, 1800 seconds, you need to make it very clear before somebody upgrades that iOS that these defaults have changed, because it can impact their network. This is why networking companies are very careful about changing a default. You can change it, but as far as their default, it's not something they take lightly. Matter of fact, I remember when Cisco iOS by default did not route IPv4 packets. You had to enable that. And I remember when we went from class full to classless addressing, okay? All of a sudden you had to recognize, yes, the address didn't represent the subnet mask. We didn't have based on the first octet. So, it's just, it can have a very large impact. Comcast deals with home users. These routers, anyway, are residential. People aren't, it probably won't have little, if any, effect if they change. And they have changed it over the years, I've noticed. Now, the sending every 3 seconds and, how long this is good for, 180. We're going to see that this actually also matters. Okay. As opposed to the 200 seconds here. Okay. We're going to see that it also matters. Let me get to this last slide. I'll make a little slide out of this here. I want to erase, there we go. Let me get to this last slide here. This here. Okay. We're going to see here later. Okay, next week. Hey, here's my link local address. Only good on the link, this link here. Okay. Now we're going to see I also have this auto configured secure. This is my permanent address. Okay. We're going to talk about these lifetimes. So yes, I got a permanent address. I created it myself. This was from the prefix length that was sent, and I created it. And we'll talk about this is how long this is good for. This is anybody trying to reach me. Let's skip down here. This is my temporary address. I created this myself. This is what I use. I say I created, my computer created. Again, using the advertised prefix 1, 2, 3, 4. So here's the prefix of my network. This is the interface ID. If anybody wants to reach me from the outside, they can reach me using this address. We'll talk more about that. Okay, we'll talk about that this in a moment. This is the address my computer created also with this interface ID. This is what I use when I'm connecting to other devices. It's temporary. This will change. Matter of fact, we'll see this here in a moment, Tuesday. I used to have a couple of other ones. These are temporary addresses also, but they're no longer, this is what I'm going to use for new and recent connections. Well, what about these? These are outdated ones that I used to use, but they're still on my system. Why is that? Because I might have, and I did. These here is for connections I had to other devices and still do have those connections, but they are, what's the word I'm looking for? They're older connections. This is the new one. It's changing constantly. We're going to see it changes every 300 seconds. I get a new temporary address. This is amazing with Comcast. Every 300 seconds. What is that? Every, what did I, about 4.5 minutes? No, 3.5 minutes. Okay. 3 times 60, 180, 4 times 60, about every 4.5 minutes. No, 5 minutes. Sorry, 5 minutes. 5 times 60, 5 minutes. Every 5 minutes, my computer is giving itself a new address to use for new connections. Make a new connection, Rick, in the next 5 minutes. Hey, use this address. Wow. And it's good for the next 5 minutes. Any new connections you make, you're using that new address. Don't worry. If you already have a connection established with what we call a deprecated address, no longer being used for new connections, they're still valid. We're not going to cut you off. Those can still be used. But as soon as that address is no longer being used by any of your existing connections, existing, I think is what I was looking for. As long as when you don't have any more existing connections, okay, then we'll remove it. So it's still good for a while. Okay. This constantly changes your address. Okay. Comcast is very privacy oriented. IPv6 is in general, but it's saying, don't worry, nobody's going to be able to know exactly what, that you're 5 minutes, I'm giving you a new address for every new connection. So let me just say that once again. I know we're a little bit over time here. For any new connections, I get a new address, I get a temporary address. This is valid for the next 5 minutes for any new connections, and will stay valid for 5 minutes and longer as long as it's still existing. But after 5 minutes, if I'm no longer connected to that device, then nobody else is using that address, then I will eventually remove you completely. Yep. Constantly changing who you are. Okay, a lot of good privacy there. Okay. We're going to go here in about a minute, but it's any questions on that? This is where we're going to start on Tuesday. Going to talk about these lifetimes. Going to talk about how long this stuff actually stays valid. Remember, this is how the servers are seeing you out there. This is by changing all the time. They can't keep, they're not going to be able to keep track of you by your IPv6 address, that it's always you. And when I take my computer to another network, this is all going to be different. The prefix, and my host portion, my interface ID, all going to be different and keep on changing. So they can't follow me wherever I'm going. Say, oh, that's Rick, that's Rick, that's Rick. Is this beginning to make sense? I'll talk more about this. This is where we're going to start on Tuesday. Capture this. Okay, because you're ahead of the curve with people understanding IPv6. All right. Not that you're an expert, not that it's taken me a long time to really get my head around all this stuff. Okay. So, and it always helps when I have to explain it. Helps me. Yeah, John.
So I see up top where it has the dynamic PL time of the 2002-008. Is that saying Comcast is changing your global, the subnet, basically? your network address basically it's every,
No, yeah, what this
Days?
is this is my DHCP V6 address that I got from them.
okay,
Yeah, so this is an address that they assigned to me, but this is not what's getting used. It would actually, there's actually a temporary address will always be used over a DHCP V6 address. If I wanted to use this address for whatever reason, I could. Why they give it to me, they used to not. That's something new that they just started doing. So it might be a way for their router to be able to send me, whatever, do any kind of network monitoring or send me packet, whatever. I don't know. But
Okay.
yeah, it's not something that my device would use by default.
so for your home, your Comcast, your,
Right. My laptop here would not use that by default. It would use the temporary addresses.
okay.
There's a preference, an order preference of what addresses get used for what. This is much further down on the list.
So does Comcast rotate your network address at all, your 26?
I have not seen this get updated at all. And, in Carmel, I had it for 6 years, same network prefix.
Okay, thank you.
Yeah, and it actually is to their benefit, because that way they don't need to worry about it. It's not like IPv4 where they are short of addresses. This makes it easy for them if they just assign this to my house. So my location. Yeah, so it makes it kind of nice. All right, I'll let everybody go. Thanks for hanging out with me. I'll see you Tuesday. We'll start here. Back up a little bit and then we'll start here. All right, thanks for hanging out. I'll see you on Tuesday. Have a great weekend, everybody.
Take care, you too.
Thank you.
Thanks.
You too. Bye, everyone.